Hey all you cool sabers, today we're going to take a look at what is called direct variation. And I know what you're thinking, what is direct variation? Well, I'm glad you asked. It is a linear relationship. Whoops. Oh, hold on. Turns out you have to actually... Okay, there we go. So it's a linear relationship. A linear relationship. Okay. Where one variable is a constant multiple of the other. Where one variable is a constant that my rating's getting real bad there, multiple of another. All right, so the only other term that you really need to know is constant of variation, and this is the number that relates to variables, that relates to variables that are directly proportional, that are directly proportional. I almost finished on the line. Okay. So, our first example here, the cost, C equals 20 cents multiplied by the amount of minutes spent talking on the phone. So the first thing we're going to do is we're going to say, well, what is our algebraic relation? So in other words, we got to come up with an equation. So the cost is going to be equal to, okay, we take that 20 cents, that 0.2, okay, we don't need the second 0 because we don't. And you just multiply that by your x, the number of minutes spent. So if you take 0.2 and multiply it by the number of minutes you spent, that'll tell you how much it costs. Okay? So what is the constant variation here? So that is going to be, I used to be able to get a yellow here. It's really bothering me that I can't. Oh, I figured it out. Look at that. On the fly. Figured it out. It's not really yellow. Whatever. Okay. This number here is your constant of variation. Okay? It's the number that you're just always multiplying by. Okay? So it's the same. It's that guy right there. It's the same thing. Yeah. So that's our constant of variation. All right. Equals 0.2. Okay. What does it represent? So that's going to be just our 20 cents, 0.20 per minute. Okay. It's the cost. It's always a rate. Okay. That constant of variation is always going to be your rate. All right. So for instance, not really for instance, we're going to make a table here. Okay. Let's talk about how much it would cost here. So let's say we spoke on the phone 0 minutes, 5, 10, 15, 20. All right. How much would it cost? So if we use that formula, we just multiply each of these numbers by 0.2, we would get 0, 1, 2, 3, 4. All right. That's how many dollars it would cost. So we can turn this into a nice little graph. Oh my goodness, this isn't... Okay, so let's go up by, let's say that's 0, 5, 10, 15, 20, 25, 30. That's a 30. We'll call that minutes. And then we'll do cost along the y-axis here. And so we'll make that 1. Whoops. I didn't even know I hit that. 1, 2, 3, 4, 5, 6. And of course we should put the units. I can't turn this sideways so that I can do that properly. I hit the red again. Anyway, whatever. The point is, we can now just fill in our values here. So we could have 0, 0. 5 was 1. 10 was at 2. 15 was 3, and 20 was at 4. Okay. And so that gives us our graph here. Okay, so then you know what? We're going to add ourselves a little line of best fit here. See if I can do this. This it is almost impossible to use a ruler. Yep. So see what just happened there? That's what happens when you try to use a ruler on this thing. Try something else. Let me try. No, that's still messing it all up. Well, you know what? I'm just going to freehand it. Let's just zoom in really far so that I can look at that perfectly straight. I'm actually going to continue it. Fortunately, it worked out really well on the grid, so I can approximate very well. Anyway, that is our line of best fit there. So the next question is, if one spends 30 minutes talking on the phone, what is the cost? And we're going to use the table, the graph, and the equation. So the table's not going to work super well, but first we'll use our graph. That's always the easiest one. So it says 30 minutes, so that's here. So we follow it up, and we go over and we say, well, look at that. It's going to cost $6. Okay, so we can actually check that using our equation fairly easily. Okay, so C equals 0.2x. We sub in 30, and we say, what is 0.2 times 30? And wouldn't you know, it gives us the same answer. And so finally we could use the chart here, and you can see it's going up by 5s over here. It's going up by 5s. So we go up another 5 to 25, and another 5 to 30. And this one's going up by 1s. So we continue, we get 5, and we get 6. So it gives us the same answer. So we're probably right here. All right, so our conclusions on a graph. If two variables vary directly, the graph will pass through. We didn't actually specifically mention this, but this is kind of what's important here. The most important thing about is that guy right there. That's I went a little, got it carried away there. There we go. Okay. The important part is for direct variation. If one variable is 0, the other variable is also 0. So it passes through the origin, which of course is just the point 0, 0. That's what makes it direct variation. As an equation, if the two variables vary directly, it will follow the pattern. So you'll get something, it'll be something like this. It'll be y equals, and then you'll have a number, which we're going to call m, and you just multiply that by your x value, and that's it. It'll have that, this here will be a number. This and this will be, those two will be variables. They might be y and an x, or it might be a c and an x, or a c and a d. I don't know. Who cares? Okay? The point is that the m is the number. Okay? And that's it. So, until next time, go Zabers.